So today we will be discussing on one of the key aspects which is important in epidemiology is to really to be able to measure the disease. And for us to really measure the disease, we use what we call measures of disease frequency. Remember, from the definition of epidemiology, we are saying we want to study the distribution of disease in terms of place, person, and time. And for us to understand that distribution and also understand the risk factors which might lead to disease, we need to have some way of measuring. We need some parameters which we use to measure these aspects. So today we'll discuss cases and measures of disease frequency. So in terms of the objectives, what you need to understand, you need to be able to define and calculate a range of measures of disease frequency, which include risks, rates, odds, and prevalence. Be able to select the appropriate measures for different contexts. Be aware of the importance of clear case definitions and potential for measurement error. So remember, it's just a recap of the definition to say epidemiology. It involves estimating the frequency and distribution of disease in a population and investigating the effect of suspected risk factors on the frequency of disease. So there's an element of just getting the descriptive where we are describing the distribution, then the element of analytic where we then want to assess risk factors for getting the disease. So for us to really pick up this concept, it really means we need to have some parameters which we use to measure. So in terms of measures of disease frequency, why do we need these measures of disease frequency? We use these tools to quantify how common an illness is in a population during a specific period of time. But for us to really be able to quantify how common an illness is in a population during a specific period of time, we really need to, first we need to know what are we measuring. So from what are we measuring, that's the outcome of interest, or we can actually define it as the case. Then we also need the size of the population or the population in which this outcome of interest is occurring, then time. So those three aspects, they are very important for measures of disease frequency. We need to understand what is exactly this outcome of interest we're measuring. What is the size of population this outcome of interest or this disease is occurring? And at what time are we having this disease? So for example, we can use this example. Let's say you want to, this is an example, for example, incidence of tuberculosis in Brazil. So this can be, to really quantify or explain this can be really said as 50 new cases of TB. So by this, we are using the case as a definition. Or we can say, then we can actually expand this further to say we have got 50 new cases of TB per 100,000 people. That's the population. Then over a period, which is a year per year. So by combining all these things, we can actually really understand to say, yes, we want to say in Brazil, they've got TB. If you just say 50, it might not really make a lot of sense. But if you then put the population which you are referring to, the period which you are referring to, it then really makes a lot of sense. Then one of the things which is of interest now, for us to be able to measure, what is important for us when you are measuring is for us to understand our outcome of interest. What exactly are we measuring? So these are like our cases. So we need to have a clear definition. Remember, from the definition of epidemiology, which we discussed in the earlier lectures, where we're saying we're talking of health events, or we're talking of, it's not like really we're measuring diseases. There are several. It depends in terms of our outcome of interest, what would be really interested in measuring. So our outcome of interest can be an infection, can be a disease, can be death, can be physiological measurement, e.g. weight, or usage of health services, whatever. So remember, it can be anything as long as it is, it is something which we are interested in terms of epidemiology or in terms of health issues. So our outcome of interest, whatever you might need to measure, it can vary. It's not like really we're measuring disease, but it can be anything as long as it is of public health importance. But what is important now in terms of our outcome of interest, what we are measuring, we really need to be able to have a clear definition. This is what defining a case. We need to have a clear definition, because if you don't have a clear definition of what we are measuring, it will be very difficult. So if you've got a clear definition of your outcome of what you're measuring, it then makes it easy and to count your things and to compare your things and to have some standard. If you don't have a clear definition of what you're measuring, then your measures of disease frequency, there will be a challenge. So it is very critical and very important to have a clear definition of your outcome or your definition of your case. So what are some of the issues which you need to consider when you are defining your case? The first one is the methods to identify your case. So remember, let's give, for example, you want to give a definition of malaria. Someone has malaria. You can define malaria, clinically, and by clinically, we are referring to the signs and symptoms, which says if someone presents, you want to measure a disease or a problem. If someone presents with fever, they are hot body, they've got chills, they've got dry gas, they've visited maybe a place where there's malaria, then that person can be defined as malaria and as a malaria case. Or you can say, no, we don't, since the symptoms are not specific, we can define, someone with malaria as someone who have got a lab test which is positive. So it is very clear. It is very important, before you start measuring whatever health events or diseases which you want to measure, it's important to have a clear definition, and your definition should be very strict, and should have some standard, so that you don't miss. Remember, the problem of not having is a definition which is standard. You either miss some of the things, or you can actually either you miss, or you can count things which are wrong because of a wrong definition. So it's very important to have your methods, how you're identifying. Are you using a lab test, or are you using a clinical? Then it is also important to have a boundary of your case. Remember, if you are using the same example which we are using for malaria, you can have asymptomatic malaria where there are no symptoms. You can have mild malaria. You can have moderate malaria. You can have severe malaria. So you need to kind of have some boundary of your case, in terms of really, this boundary refers to the limit which we are going to consider as you will be collecting your data, as you be counting. So some of the outcomes, they are continuous, like blood pressure. Are you going to take all the blood pressure measurements, or you're going to have a cutoff? So I think you're also going to see the importance of boundaries when usually when you're talking of outbreak. Maybe you're measuring there are cases of a disease which have happened within an area. So you need to have some boundaries now. These are like geographical boundaries. So you can have some of these boundaries depending on the severity, or you can actually have geographical boundaries. If a case, let's say you've got two communities. One of the community, their cases, other community, their cases. Are you going to count all the cases in both the communities, or you are going to really specify, specify your cases within whatever community we should be dealing? So it's very important to make sure in your definition you put a boundary. Then some of the things, some of the events, you can have multiple events. For example, in this, there's an example of diarrhea. So when you're counting in terms of a definition, you also need to be very clear the limit of a definition to say, am I just focusing on the first case or I'm counting all episodes? So you need to be really very clear there, because now if you really count maybe 1%, you're counting them twice, they've got a recurrent event. So it means actually you can end up having more cases than the actual cases. So you need to be very clear what exactly you're counting. So for your measures of frequency, this is very, very important to have a very clear definition, because if you don't have a clear definition, you will end up underestimating or overestimating, and in some of the cases, either you include wrong cases or, yeah, so which is very important. Then after really defining your case and understanding your cases, we have two main types of measures of disease frequency. We have what we call prevalence, and we have what we call incidence. Then prevalence is the frequency of existing cases. Frequency, it just means the count or the number. So if there are 10 things, the frequency is 10. It means you've got counted 10 things. So frequency, it just means the number. So prevalence is the frequency of existing what cases. Then incidence is the frequency of new cases. So the difference between prevalence and incidence as measures of disease frequency, we say prevalence is the frequency of existing cases, but incidence, it then refers to the new cases. So if you've got a condition, whether it's a disease or it's a health event or whatever you're measuring, you might have already, people with that condition within a population. That's the prevalence. The new cases which you get, that's the incidence. So existing cases are called prevalent cases. New cases are called incident cases. So let's start with prevalence. So as we said, prevalence is a measure of frequency of existing cases. Or we can say is the proportion of people in a defined population that is the outcome of interest at a specific point of time. That's your prevalence. So how do you calculate prevalence? Is the number of existing cases at a time t, then over the total population. This is like an example of prevalence. With the percentage of people with malaria parasites in their blood in a village in Tanzania in a survey in 2011. You go to a village. In this case, we want to see the number, or we want to see the prevalence of people with malaria. What do? We test for people, and we have got the population of the community, which is the total population. Then we test the number of people with malaria. So in this case, our prevalence, it becomes a percentage or a proportion where we put the number of people with malaria over the total population. So another example is the proportion of the population in India that is diabetes. So we take the whole population of India, we count the number of people in India, which is diabetes. So that proportion, it then becomes a prevalence. So prevalence, just to repeat again, is the proportion of people in a defined population that is an outcome of interest at a specific point of time. And this is the formula which is given there. Then maybe I need to give another before we move to the next thing, which is incidence. So let's take, for example, in a class, we want to, we have something which we have a class of 20 people. In that class of 20 people, let's say we test for HIV. We found that out of the 20 people in a class, 10 of the people, they are HIV positive. So the prevalence of HIV in such a class, it will be 10, those who are positive, over the whole population of the class, which is which is 20. So we get a prevalence of 50%. So the number of cases at a time over the population at that time, it gives us what? A population. Then if you go now to the next parameter of measure of measure of frequency, which is incidence. As we say now, incidence is a frequency of new what cases now. Existing cases, that's prevalence. New cases, that's incidence. And so this is an example now. Over a 1 year period of all people in Thailand, 9% had at least one episode of influenza. So we are saying over a period of a year, what do we say? How many new cases did we have? 9% at least one episode. So remember, so there's the element of new episodes, people developing some influence. We can measure incidence using two elements which we can use to measure incidence. So incidence can be measured either using risk or rate. What is the difference between these two? Risk, it just relates to the number of new cases to the size of the population at risk at the start of the study period. That's the risk. And I'll show you the formula. Rate now, it relates, the difference between the rate, it relates to the number of new cases to the percent time at risk. So rate, it takes into account the change in the size of population at risk during the follow-up period. Rate, it is an element of time, and it, remember, when we are measuring, when we the population is not static, and the population the population usually within a community is not static. The population will be changing with time. Some of the people will be getting infected. Some will die. Some will get infection. Some will move out of that community. So because of that, the population is not static. So by rate, we are taking into account the change in the size of population, and it is the follow, and it is as you follow up as time moves on. But for risk, we don't really take into account. We don't really take into account the change in population with time. So most often you're going to realize that this term risk and rates, they are used interchangeably, but it's wrong. They are different. Risk, it just relates to the number of new cases over the population. Whilst rates takes the number of new cases, but it takes into consideration the change in the size of the population. And for rates, we talk of what we call the percent time years and at risk. We are going to explain this. These two things, they are not the same. They are different. They've got different formulas. But when you're looking into rare diseases, risk and rates, they are the same. So let's start with one, which is risk. So we say, what is risk? Risk is the probability of occurrence of disease during a defined period of time in a population initially free of disease. And so what is risk? Number of new infections during a defined period over the population initially at risk. So this is a simple example. So risk is the number of new cases over the population at risk. So D is the number of new cases, which is the numerator, and N is the population initially at risk. So remember, just to recap before I go, so that we don't lose each other. With our incidence is a measure of new cases. But there are two parameters which we use to measure incidence. We use either risk or rates. Then for risk, which we are discussing now, it's just the probability of occurrence of a disease during a defined period of time in a population. And how do you calculate it? Number of new cases during a defined period over the population at risk. So these are this is the formula. This is an example. Let's take the example at the University of Zimbabwe College of Health Sciences. What is the risk? The risk of a student at the college eating a burger during the 12 months from October 2014 to September 2015 inclusive. So the population at the college is 800 students. Out of those 800 students, 200 of those students, they reported having ate a burger. So remember, as I explained from the start, these measures of whatever, these measures of frequency, it's not always about diseases. In this case, we are looking at the incidence of eating of eating a burger. So out of the 800, 200 ate 200 ate a burger. So what is our population at risk? There were 800 students. But how many new cases or number of people who ate a burger? There were 200. What is our period? Our period is from 1 year, 2014 to 2015. So our risk becomes 200 over 800, and we get 25%. Another example, I think these are the same formula here, and where we're saying our formula is number of cases during a defined period over our population. This is very important for you to understand. And the risk is what is a proportion. And remember, we need to understand these things. What is a proportion? What is a ratio? So a proportion, usually a proportion, it means the numerator and the denominator, and they are the same. They're oranges. All of them, they're oranges. But can I be a ratio? You can have the ratio of male as to female. They're not the same way. And so read about those things, about those. What is the difference between a proportion and a ratio? But this one is what is a proportion. Why? Because at the top, what is on top and below is the same. So it varies between 0 to 100%, or it can be between 0 and 1. If you express it as a percentage, it's 0 to 100. But if you don't express it as a percentage, it's 0 to 1. Risk refers to non-recurrent disease or to the first episode of the disease. Which other names are used for risk? You can have what we call cumulative incidence risk, or or a probability. So they are used interchangeably, these two words. Then this is an example of a risk where in a study of men aged between 30 and 59, who were remember, they were initially free of coronary heart disease. And then the risk of developing CHD in the year, it was 58 per 100,000. So it can actually be expressed per population. Remember, when it started, we discussed these issues, which were important to say. You might need to put, when you're reporting these measures of frequency, you need to have the number, you need to have the population, you need to have the period, so that it becomes, you can fully understand that. What are the examples of, these are just two examples, and you can measure risk. You can measure risk in different subgroups or strata of population. For example, different age groups. In the same example, which I gave, for example, you can look at the risk for men aged between 30 to 39, 40 to 49, and 50 to 59. So in this example, you see, the risk of getting coronary heart disease is increasing. And for the lower age group, it's 31 per 1,000. But for the lower group is as the age increases, the risk becomes higher. So this is for the 40 to 49 age group, it's 66, 131 for the age group 50 to 59. So actually, it's another way of which can be used to present risk. Then we have what we call odds, and we use odds. What are odds? Our risk, the formula is the same: number of new cases during a defined period over the population initially at risk. Then for odds is a ratio of people who get the disease to the people who do not get the disease. So it's different. For odds, we are saying odds is the ratio of people who gets the disease to the people who do not get the disease. So the number of new cases in a defined period of time, those who get disease over those who didn't get what? The disease. That's the odds. But for risk, we use the population at risk initially. So remember, one thing I forgot to explain. Why do we say population initially at risk? And if you already have the disease before, let's say you already have the condition, it means you're no longer at risk. You can only be at risk if you are free from what? From the disease. So understand that difference. So let's take an example where I want to calculate the risk and odds. Observe a lecture of theater of 200 students for 1 hour. The outcome of interest is sneezing at least once. 50 students, they sneezed during the lecture. What is the risk of sneezing? So in this case, the risk of sneezing, from our formula, number of new cases during a defined period over the population initially at risk. Our population is 200. How many people sneezed? There were 50. So the risk of sneezing is 50 over 200. You get 25%. Then our odds, from our formula for odds, what is our odds? We say our odds is number of new cases in the defined and the number of non-cases. So during this period, we have 50 cases and 150 out of the 200, 50 sneezed. Then 150 did not sneeze. So our odds now, these two things are what they're different. And so the odds here is 50 over 150. You get 0.33. And the odds cannot be expressed as a percentage, and they're different. We are going to discuss more of the odds when we are discussing case control studies. But at the moment, just understand we have what we call odds and what we call risk. So the odds of sneezing is 0.03. The risk of sneezing is 0.225. Then the next measure of incidence, which we've discussed risk, the first one. Now we are now discussing the next one, which is incidence now, where we are talking of what? Of rates. So what is a rate? A rate relates to the number of new cases to the person, to the person time at risk. A measure that takes into account changes in the size of the population at risk during the follow-up of period. How do you calculate a rate? Is the number of new cases over the total person time. So the total person time, remember, as I said, during a time period, the population at risk will always change. Some people will die, some people will develop the disease, some people will whatever, some people will migrate or whatever, or other new people, they come within the population. So the rate, it takes into account the fact that population is dynamic, is not fixed. So we then try to see now, during the period which we are measuring our incidence, we take into account the difference in the follow-up time of the population. So in this case now, our numerator is the number of new cases, but our denominator is the total person time. What is this total person time? Is the follow-up time per each individual. So what is this person time? What is this person time at risk? It's a measure that takes into account changes in the size of the population at risk during the follow-up period. And this person time years is the sum of the time each person in the study, not in the, each person in the candidate, whatever, Canadian study, then that's fine. But if not a study, it is the sum of time each person in the community or population remained at risk during the study period. Remember what I said from the start. If you if you check with the formula for risk, is the population initially at risk. But as time moves, the population at risk changes because others who already have disease. If you have a disease, it means you no longer have you are no longer at risk, which means as time goes on, that will be changing. So this is an example, and the person time at risk Once someone has died, they cannot die again. That's the same concept I'm saying. But if you're at risk of developing, let's say, malaria, if you develop, some of the things actually they can recur, they can come once in a while, but there are some events which don't repeat. For example, which is like death. So in this case, once a person has died, they cannot die again. They are no longer at risk again, and this person. Their observation period is the time before they died, and that is the person time at risk. The period after they die, and it does not contribute to the denominator. So in this case, let's say our outcome of interest is what is let's say our time of interest is what is and it is death. So it means and the person time. It means now we are following our person. Let's say from here to here, that's a year. So this follow-up time up to where they die, that's the person time what at risk. As soon as they die, it means we are no longer following up because we already have our outcome of interest. So let's have an example. 3 people are observed and the outcome of interest is what is death. 1 person is observed for 6 years. They are alive. They move away and they cannot be traced. 1 person is observed for 4 years, then they die. Another person is observed for 10 years, they are alive, and when this time whatever ends. What is the total time at risk? So this one was followed for 6 years, this one for 4 years, this one for 10 years. It gives us a period of what? 20 years. Out of all these three people which we followed up, only 1 person had an outcome of interest, our case, which was what? Which was death. So what is the number of new cases? That's 1. So what is the rate of death? Is 1 person over 20 person what years. And this gives you 0.05 and 0.05 over. Remember, you can change this and this one, it gives you 0.5 whatever 10 per 10 and per 10 years. You can change this into like if you divide by 2 and you'll get 0.5 over 10 years. If you multiply this by 10, it then becomes 5 and 5 deaths per 100 person years, and it becomes this. So I think this is an example. But one of the things you need to understand, which is important for rates, our denominator is the population. What is the total person? And this total person is the time which people have been followed up. And this one you can read it alone and about your denominators to say you can actually the same way I was saying with 0.02 person per person years. If you multiply this by by 10, it becomes 0.2 per 10 years. If you multiply this one by 100, it becomes 2 and it becomes 2 per 100 years. If you multiply this by 10 again, it becomes 20. So they are the same way, but you can actually, usually when you're expressing some of these things, we always advise, to make sure you express this as like 100, at least 1,000 or 100, at least it makes sense. So if you say 0.02, it's difficult to understand as opposed to expressing it as a whole number. This one, you can also do it as a homework where you convert 4 per 9 person years into a full number. What other aspects of rates? Remember, this is the formula for our rates. Rates, they are not proportions. They are not proportions. Why they are not proportions? Remember, I explained they are different. We have got rates, we have got ratios, there were so many other things. In this case, what is in your numerator? These are number of cases, and what we have below is time. So it cannot be a proportion because what is in the numerator and denominator We have got apples and oranges. So this cannot be what? Cannot be red. What are the names which are used for rates? Again, they can be called as incidence rates, incidence density, force of morbidity, or these are the words which are used. And then we got recurrent diseases. And this one, remember, as I mentioned, infective diarrhea. So this one is a bit different and for rates. So it's usually a challenge to calculate rates for recurrent disease. Why? Because one person can have more than one episode. But in most cases, when people have got diseases which are recurrent, if you want to get the rate, you can actually use the first episode as opposed to counting all the episodes. Otherwise, it will not make a lot of sense. Then this one, we are just trying to explain, when do you use choosing between risk and rates? If a disease is rare and the population is stable. So remember, if the population is not changing and the disease is rare, usually a risk and rate, they always give you the same value. But if the population is not stable and the population, remember, population stable rates, they take into account the fact that the population will be changing with time. But if the population is not changing and the disease is rare, a risk and the rate, they tend to equate each other. And this is an example for you, which I want you to, when you get the notes, to say, what is this? A study of 4,000 adults in England measured whatever, and you get these notes. So I want you to answer this to see, what is it? Is it a rate? Is it prevalence? Is it what? Is it incidence? What are some of the common errors which happens when you are measuring our disease frequency? One, you can have errors in cases, and which is your numerator. Usually, remember, as I highlighted from the start, it is very important to have a clear case definition. If you don't have a clear case definition, then it means you end up having an error in quantifying your cases, and this will then give you a wrong measure of frequency. So it is important to have a clear case definition. The same can also happen with the population. And the same can also happen with the population, where you might have errors, in quantifying your population. So it is also important to make sure you use the correct denominator and the correct numerator. So if we make errors between those two parameters, you will have challenges. So just to summarize, remember what we discussed is, what are these measures of disease frequency? We use those to quantify how common an illness is in a population over a specific period of time. And for these values to make sense, you need to make sure our outcome of interest is very clear. We have our population, and we have time. What two measures do we have? We have got two types of measures. We have got incidence, those are new cases. We have got prevalence, those are existing cases. Our prevalent new cases, they're called incident cases. Prevalent existing cases are called prevalence cases. This is the formula for prevalence. But don't forget, for instance, we've got two things. We have risk. We can measure our incidence using risk, or we can measure our incidence using rate. Rate, it takes into account the difference in the follow-up time. Whilst incidence, it just takes the initial population, and the initial population at risk when you start. Then this is the formula. This was the formula for prevalence: number of existing cases at a specific time, then population at the time. Then for your rates, and for your risk, it's population at risk initially, then your number of cases, then your rate, number of new cases, and your denominator is the follow-up time, which is the total. For rare diseases, remember, as I said, when do you choose whether to use a risk or a rate? But we said for rare diseases in a stable population, risk and rates, they are what? They're the same. Remember, we said the rate, it takes into account the change in population. But if the population is not changing and is stable, then these two, they tend to be similar. Then risks, a probability, they range from 0 to 1. If you put it as a percentage, it's from 0 to what? To 100 what? To 100%. So remember, as I said, you can have errors as you're measuring these measures of parameter. So even though these things, they sound very simple, everything can actually, things can go wrong if you don't really, if you have got errors. What is important is to make sure you have your numerator and your denominator, they are what? They are correct. Otherwise, I think this is the end of this lecture on measures of disease frequency.